Hi, welcome to ChemTube channel. I'm Jaegu Wong. In this video, we are going to discuss the SBP Trial Paper 2, year 2021. Let's start. Okay, first we look into the section A. There are 8 structure questions. Question number 1. Okay, protium, deuterium, and tritium are isotopes of the hydrogen elements. So diagram shows the atomic structure for these 3 atoms of hydrogen. Okay. So you can have a look here. So protium, deuterium, and tritium. So first question, what is the meaning of isotopes? Okay, isotopes. So isotopes are atoms of same elements with the same number of protons or proton number, but different number of neutrons or different nucleon number. Okay. B, state the name of all subatomic particles inside the nucleus. So we have to focus the nucleus here. So inside the nucleus we have proton and neutrons only, not include the electrons. C names the subatomic particles that is negatively charged. So this one is the electrons. So do the 3 hydrogen atoms in diagram have the same chemical properties or not? Okay, explain your answer. So based on this question, so we have to know that if their valence electron is the same, so meaning that they have the same chemical properties. So the answer is yes. Okay, yes. Why? Because they have the same number of valence electrons. Because they have the same proton number, meaning that electrons will be the same. So they have the same electron arrangement. But when focused to the chemical properties, we are going to explain the valence electrons. Okay, question number 2. Okay, so state the size. Diagram shows the electron arrangement of gas A. So if we look into this diagram, so it's NH3. So we know this is ammonia molecule. So state the type of particles in the gas A. So this one, because of sharing of electrons here, so we know it is molecules. So what is the purpose of chemical bond formation? So the answer is to achieve the stable duplet or octet electron arrangement. So we have to mention if for duplet, right? Duplet is for hydrogen because it will achieve duplet electron arrangement. So 2 electrons. But for the nitrogen here will be achieve the octet electron arrangement. So 2, 4, 6, 8, 8 valence electrons. Now based on diagram, state the type of chemical bond in the gas A. So we can see it is a sharing of electrons, right? So it's a covalent bond. So explain how the chemical bond is formed here. So there is 2 marks here. So 3 atoms of hydrogen share a pair of electrons with 1 nitrogen atom, right? Then 1 atom of nitrogen contribute 3 electrons, and 3 electrons of hydrogen contribute 1 electrons for sharing. Okay. Okay, question number 3. Diagram 3 shows the symbol of an atom of element X. The letter used is not the actual symbol of the elements. So here we have a look here. It's the X. This is the proton number. This is a nucleon number, 35.5. So what is represented by the number 17? So 17 here, actually we know it is a proton number. So state the period of the element X in the periodic table. So for this question, right, we have to look into the proton number 17. So electron arrangement will be 287, right? So if 287, so the period will be looking into the number of electron shells here. So there are 3 electron shells occupied with electrons. So it is in the period 3. So X reacts with hot iron wool to form a brown solid. So write the chemical equation for the reaction occur. So X here is the chlorine actually. So you can replace with the X here. So iron react with the chlorine, produce iron 3 chloride. So if you don't want to use the X chlorine, so you can replace with X. So X2. So you produce the iron 3X. So iron react with X, okay, 3. Also accepted, both answer here. So next question, okay, calculate the mass of the brown solid form. So brown solid here is F iron 3 chloride, yeah? Iron 3 chloride. So when this is 0.3 mole of X react with the hot iron ore. Okay, so here we can have a look here. So 3 mole of the chlorine produce 2 moles of iron 3 chloride, right? Okay, so this is the one. Okay, so if 0.3 mole of the chlorine, so it's 0.2. Okay, we can see. If you cannot get the direct answer, you can use a cross multiplier. So if now you have 0.2 mole of the iron 3 chloride, so the mass, okay, so it's the mole times the molar mass is 162.5, so you get 32.5 gram. Okay, so 2 marks. Unit must be stated correctly in your answer. Okay, question number 4. Diagram shows the apparatus to determine the empirical formula of the oxide of copper. Okay, so here is a hydrochloric acid react with the zinc, so you produce the hydrogen gas. So hydrogen gas pass through the hot copper powder, oxide of copper powder here. Okay, then they will react. Then the excess hydrogen gas is passed through the water here. Okay. Now, what is the meaning of the empirical formula? So empirical formula is a chemical formula that shows the simplest ratio, okay, simplest ratio of the number of atoms of each element in the compound. Okay, simplest ratio of atoms of each element, okay, in the compound. Now, what is the role of zinc granules and hydrochloric acid in this experiment? So just now we mentioned already is to produce a hydrogen gas. Name another oxide of metal which the empirical formula can be determined using the same method. So this method used for the unreactive metal such as copper and lead. Lead 2 oxide also can, silver oxide or tin 4 oxide. Okay, you can choose any one of these unreactive metal. Table shows the result of experiment obtained by a student. Okay, mass of the glass tube is 9.25. Glass tube plus the oxide of copper is 9.35. Mass of the glass tube with the copper, this one is after the experiment. After experiment. So 9.33. Yeah? Okay. Calculate the mass of copper. So copper, we can use the data from the table. So it's 9.33 minus 9.25. So we will get the mass of the copper is 0.08 gram. The mass for the oxygen, okay, 9.35 minus 9.33, so it's 0.02 gram. So next, calculate the number of mole of the copper atom and the oxygen atom, and then determine the empirical formula for the oxide of the copper. So from the first question just now, the mass of the copper and oxygen is calculated, so we can calculate the number of mole for the copper. So the mass 0.08 minus divide by the molar mass 64. So the mole will be 0.0125 mole. Meanwhile for the oxygen, okay, 0.02 divided by the 16. Okay, so here be careful, not divide by 32, it's divided by 16. Okay, so you also get the same number of mole. So we can do the mole ratio, okay, for copper and oxygen is 1 to 1, 1, 1. So meaning that we can get the empirical formula of the copper 2 oxide is CuO. Okay. Now, question number 5. Table shows the sodium hydroxide solution with different concentration. So given to you R and S. So concentration is for R is 0.1, for S is 0.001. Okay. So for the pH value, this one is empty. So this one is 11. So first question, what is pH? pH stands for what? It's a logarithmic measurement of the concentration of hydrogen ions in the aqueous solution, or negative log concentration of hydrogen ions. So now calculate the pH value of the solution R. So here solution R, we can use the formula POH. Negative log concentration is 0.1, so you get 1 POH. Okay, but be careful here, this is POH, not the pH. So how to get the pH? We know that pH is 14, so minus the POH is 1, so it's 13. So pH for the R will be 13. Okay. Now compare the pH value of R and S. So we know that the pH value of the R is higher than S. Okay, explain the answer. Why the pH value of the R is higher? Okay, here we know that the concentration of hydroxide ions in the solution R is higher than solution S. Okay, so the higher the concentration of hydroxide ions, the higher the pH value. Okay, now diagram shows the heating of the solid T. Okay, solid T is a white color. When you heat it, it forms a yellow solid when hot and white solid when cold. So if you have memorized this, okay, this is the observation for zinc oxide. Zinc oxide. Then another one, it will release a colorless gas which turns the lime water cloudy. So this one is the carbon dioxide. So in other words, we know this is the zinc carbonate. Okay, so write the chemical equation for the heating of the solid T. So zinc carbonate produce zinc oxide and carbon dioxide gas. Okay, diagram 6 shows the series of reaction involve the compound P, C2H5OH. Okay, so this is the one, compound P. So we know, so if we look into the formula, we know this is the ethanol. Okay, ethanol. Okay, so ethanol undergoes the dehydration, so it forms the ethene. Okay, then it undergoes a reaction 1 and yeast, so you can produce the glucose. So this is called fermentation. Okay, and then the alcohol react with acidified potassium dichromate 6. So this is undergoes oxidation. Okay, so it undergoes oxidation, so it forms the carboxylic acid, ethanoic acid. Okay, so I encourage you all to write out all the important information, then we can start to answer the question. So state the name of the reaction 1. So reaction 1 is a fermentation, right? Okay, now state the name of the compound P, so it's the ethanol. Okay, write a chemical equation for the complete combustion of compound P. So ethanol react with oxygen, produce a carbon dioxide in water. So we need to balance the chemical equation. So we start with carbon, so C2. So carbon dioxide C times 2. So hydrogen 5 plus 1, 6. So 3 times 2, 6. Then finally we check the oxygen. So 2 times 2, 4 plus 3, 7. So here 1, so 3 times 2, 6, so 7. So it's a balanced chemical equation for the combustion of ethanol. Now, based on the diagram, choose 2 substances that can react to produce a compound with a sweet smell. So here, we know that sweet smell if it under ester. Ester is combination, a reaction between the alcohol with carboxylic acid, right? Okay, so alcohol is a ethanol, the ethanoic acid, or P and S. Okay. Now, draw the structural formula for the compound form. So it will form the ethyl ethanoate. Okay, right? Ethyl ethanoate. So, okay, so this is the ethanoate functional group for the ester. So, okay, this is from the alcohol. This is from the carboxylic acid. Okay. Now, table shows the observation when gas R and the ethane gas are delivered to 2 test tube filled with the bromine water separately. So, gas R, brown color of the bromine water turns to colorless. Ethane, brown color of the bromine water unchanged. Okay, so meaning that this one no reaction, this one it has the reaction. So explain the differences in the observation in table 6, so 3 marks. So first point, so gas R, it will react with bromine water, while ethane gas does not react with bromine water. So compound R has double bond between the carbon bonds, or compound R is an unsaturated hydrocarbon, so it can react. No? Okay, meanwhile for the ethane gas, it has single bond between the carbon atoms, or it is a saturated hydrocarbon. So that's why there is no reaction between the ethane gas with the bromine water. Okay, question number 7. Okay, diagram shows the energy level for the precipitation. Okay, for precipitation, it can be endo or exothermic, but here we know it is exothermic because the negative sign. So state the meaning of the heat of precipitation. So it is a heat change or heat release when 1 mole of precipitate is formed from its ions in an aqueous solution. Okay. Now state the color of the precipitate form. So silver chloride is a white color. Okay, next calculate the temperature change when 25 cubic centimeter, this is a volume, of 0.5 mole per cubic decimeter. This is a concentration. Silver nitrate solution react with 25 volume concentration 0.5 SEMA sodium chloride solution. Okay, so here we can calculate the number of mole first for both sodium chloride and silver nitrate. Okay, 0.5 times 25 over 1000, so you get 0.0125 mole. Okay, so given in the question the delta H is negative 65.5, so we directly change to joule, so it's 65,500, so times mole, so you get 1818.75 joule. Okay, so this is a Q. So from Q here we can do the calculation for the Q equals to MC theta. So here if we want to find the theta, so it's 818.75 divided by the M is 25 plus 25 times the C, so you get 3.9 degrees Celsius. Okay, now the reaction is repeated by using 25 cubic centimeter of sodium potassium chloride, so initially is sodium chloride, okay, to replace the sodium chloride. Okay, so predict the value of the heat of precipitation for the reaction. So explain your answer. So what do you think the heat of precipitation would be? Remain the same. Why? Okay, because the number of the silver chloride precipitate formed is the same. Okay, sodium ions and potassium ion are not taking part in the precipitation of the silver chloride. Or you can write sodium ions and potassium ions are spectator ions. Okay, or only silver ions and chloride ions can react during the precipitation. Okay, next, based on the table 7, which fuel is more suitable to replace the petrol in the vehicle? So we can have a look here, ethanol until the hydrogen gas. Okay, so which one is the best to replace? Okay, here hydrogen gas. Okay, you can choose fuel answer, hydrogen gas. Why? Because it has the highest fuel value, or combustion of the hydrogen does not pollute the environment. Actually, you can choose another as fuel, for example natural gas also can. Okay, why? Because it is cheaper or high fuel value. Okay, besides that, you also can choose ethanol. So ethanol, because the combustion of ethanol does not pollute the environment. Okay, so any one of these answers are accepted as long as your answer is logic. Okay, now we look into the question 8. Okay, our room is the main element consists in gold. Table shows the information related to two types of gold bar available in the market. So first, gold bar A is 916. Gold bar B is 999. Okay, let's look into the arrangement of atoms. So for gold bar A, inside there got the aurum atom and the silver atoms. And then gold bar B, okay, is a pure gold. It's aurum only. Okay. So now state the meaning of alloy. So alloy is the mixture of two or more elements where the main element is the metal. And then which gold bar is more suitable to make jewelry? So we look for the stronger one. So it's gold A. Gold A. Okay, based on your answer, compare two types of gold in terms of the arrangement of atoms and to explain your choice. Okay, so gold A, it has different size of atoms, while gold B has same size of atoms, right? Then the atoms are not orderly arranged in gold A, while the atoms are orderly arranged in gold B. Okay, then layers of gold atoms in the gold A are more difficult to slide over each other when the force is applied, so that is why it is stronger. Now B, diagram shows a campaign poster related to implementation of one of the green technology program in the community. So the campaign is regarding the practice proper waste disposal. So you can help to make the clean and green dream come true. Okay, so this is a symbol of recycle, right? So recycle the plastic, aluminium, paper, and then the glass. Okay, so do your part today. So this is a campaign poster. So in your opinion, do we need to support the campaign shown in the diagram? Explain your answer. Okay, this type of question is the opinion questions. Actually, you can give the pro answer or cons answer. Okay, but you need to support your answer with reason. Okay, logic reason. So you can choose yes to make sure all the effectiveness of the waste management to improve the quality of the environment. Okay, so this is or yes. Okay, how about no? Okay, no, it is costly because not worthy, and then it is time consuming also. Okay, so my suggestion will be yes, support the campaign, although it is time consuming. Okay, next. Diagram shows a newspaper clipping related to the rubbish disposal in Malaysia. Okay, so we look into the English version. Okay, it's 14 million tons of the garbage by 2022. Okay, so there is an estimate that can be made based on the trend of daily garbage collection across the country, recorded an increase from 2012 until 2021. So here, okay, you can see the details here. Okay, so actually it's regarding the garbage. Okay, now let's have a look on the question. Okay, based on the newspaper clipping here suggests two methods. Okay, two methods involve the application of green technology to solve the problem highlighted. So what methods we can use, okay, in our syllabus? Okay, the methods. Okay, actually few methods if you can see from these diagrams. Okay, so the methods suggested. Okay, first one, composting the organic waste, solid waste, to make it to form the compost instead of dispose it directly. Okay, number two, recycling. Okay, we can recycle some of the items that can be recycled. Okay, next is incineration. Okay, actually is if you can see these diagrams, actually is the burning of the waste. Okay, in a special machine. Okay, then it can reduce the release of the toxic gases into the surrounding. Okay, next, methane gas recovery. Okay, also a method to to reduce the garbage, right? Okay, so you can choose any two. Now, give one advantage for the methods suggested. Okay, so here the advantage, reduce cost or reduce the solid waste, generate biomass energy, okay, or reduce environmental pollution. Okay, you can choose any one. Okay, to support your advantage of the methods. Okay, next is regarding the essay question. Okay, for section B, there are two, choose one. Okay. Diagram shows the two water temperature option available on the washing machine in the laundry mark. So it's the hot water, okay, and then the cold water. So based on the diagram, which water temperature option can clean the cloth faster? Explain your answer, 3 marks. So definitely is the hot water. Okay, why? The temperature of the hot water is higher than the cold water. So kinetic energy of the water molecule in the hot water is higher than the cold water. So 3 marks. Now step 2 factors that can affect the rate of reaction other than temperature. So we have size of the reactants and then concentration of the reactants. So 2 marks. Okay, B, a student carry out 3 sets of experiments to investigate the factor that affect the rate of reaction between the magnesium and sulfuric acid. So table shows the time taken to collect 30 cubic centimeter of the gas release for the 3 sets of experiment. Okay, now we have a look here. So this is the time taken for the set 1. So the concentration is 1 mole per cubic decimeter sulfuric acid. So here is the excess magnesium powder. Okay, now look into the set 2. Okay, concentration 1 mole per cubic decimeter of the sulfuric acid. Okay, but here is the granules, magnesium granules. So the time taken 90 seconds. Okay, now for set 3, magnesium granules. Okay, but the concentration is 2 mole per cubic decimeter. So the time taken is shorter, 45 seconds. Okay, now, okay, write the chemical equation for the reaction in step 3. So chemical equation. So magnesium react with sulfuric acid, produce a salt, magnesium sulfate, and then release the hydrogen gas. So the hydrogen gas collected, okay, can use it to measure the rate of reaction. Now calculate the maximum volume of the gas release. So here from the question we know the magnesium is excess. So we know the sulfuric acid is limited. So we calculate the number of mole for the sulfuric acid. Okay, so number of mole for the sulfuric acid, MV over 1000. So 2 times 20 over 1000, so you get 0.04 mole. Okay, then we need to compare the sulfuric acid with the hydrogen gas. So 1 mole of sulfuric acid produce 1 mole of hydrogen. So if 0.04 mole of sulfuric acid, so 0.04 mole of hydrogen gas. So volume of the hydrogen gas, number of mole times the molar volume 24, you get 0.96 cubic decimeter. Okay, now compare the rate of reaction for the reaction between set 1 and set 2. Another one is set 2 and set 3. So explain your answer based on the collision theory. So for set 1 and set 2, we know the factor involved is the size. Okay, now so the rate of reaction for the set 1 is higher than set 2. Okay, so size of the magnesium in set 1 is smaller than set 2, which is set 1 use the powder, set 2 use the granules, right? Okay, so total surface area of the magnesium is larger in the set 1 compared to set 2. So frequency of collisions between the hydrogen ions, okay, this one from the acid, and the magnesium atoms in the set 1 is higher than set 2. Okay, now point number 5, the only difference is frequency of effective collisions, okay, between the hydrogen ions and magnesium atoms in set 1 is higher than set 2. Okay, so point 4 and point 5 actually difference of one letter, one word only. Okay, now set 2 and set 3 is because of the concentration, alright. So the rate of reaction for the set 3 is higher than set 2. Okay, so concentration of sulfuric acid in set 3 is higher than set 2. So if the concentration of acid is higher, meaning that the number of hydrogen ions per unit volume in set 3 is higher than set 2. Okay, then point 4, the same as just now, frequency of collisions between the hydrogen ions and magnesium atom in set 3 is higher than set 2. Point number 5, the only difference is the effective collisions. Okay, yeah. So get ready for the explanation using the collision theory. Okay. Question number 10. Okay, a rubber dapper intend to collect the latex in the liquid form. However, he found that the liquid latex turned into solid after being left for a few hours. So what should the rubber dapper do to overcome the problem? Explain your answer. So 3 marks. Okay, so he can add in the ammonia into the latex. Okay, so hydroxide ions can neutralize the acid produced by the bacteria, and then the protein membrane of the rubber particles remain negatively charged, or then the coagulation of latex can be prevented. So remember. Okay, now next, an experiment was carried out to investigate the elasticity of the vulcanized and unvulcanized rubber. So there are 2 types of rubber here. So table shows the result. Okay, now one of these X or Y should be vulcanized, another one should be unvulcanized. Okay, now we want to investigate the elasticity. Okay, now we look into the rubber X first that you do for 3 sets. Okay, initial length are the same, all 12 centimeter. Okay, then we look into the length after the rubber strip with the weight, 100 gram weight. So you can see first set 12.35, 12.25, set 2, set 3 12.30. Okay, then when the weight is removed, we can see the length. Will it go back to original length or not? Okay, no, 12.10, 12.10, 12.15. Okay, so meaning that rubber X, if compared to rubber Y, so this one should be unvulcanized rubber. Okay, unvulcanized rubber. This one should be vulcanized. Okay, because you see when the weight is put on, the length is extend a bit only, stronger, then it can return to its original length after the weight is removed. So this one should be vulcanized rubber. Okay, so state the type of rubber X and Y. So X should be unvulcanized rubber, Y should be vulcanized rubber. So compare and explain the difference in average increase in the length of the rubber after the weight is removed. So average increase in length of Y is smaller than the rubber X when the weight is removed. Okay, why? Because the presence of sulfur cross links between the rubber polymers in the rubber Y. Okay, it can prevent the rubber Y from sliding each other easily. okay, or reduce it from sliding over one another. Okay, then when the weight is removed, Y are able to get back to its original position. So we can say rubber Y is more elastic. Okay, more elastic. So elasticity is ability to be to return to its original position when the force is removed. Okay. Now, shoe soles can be made from rubber X and Y. Which rubber is suitable to make the shoe sole that can last longer? I think you should know the answer. It should be rubber Y. Give 2 reasons for your answer. Okay, so it is more elastic, not easily oxidized, it is harder, okay, stronger, and then resistant to higher heat. Okay, you can choose any 2 reasons. Okay, C. Polymer are widely used in our daily life. Diagram shows uses of 2 different polymers in our daily life. Okay, so here polymer A to produce the threads that are important in the textile industry. Polymer B widely used to make the plastic packaging. Okay, now state the meaning of polymer and give 1 example of natural polymer. So polymer is a long chain of molecule that made from what? Made from combination of many repeating basic units, okay, or called monomer. Okay, example of natural polymer like starch, cellulose, protein, natural rubber. You can choose any one. Now draw the structure formula and name the polymer B to the IUPAC nomenclature. So this one should be like this, the structural formula. Okay, so this is what? This is polyethene or polyethene. Yeah. Okay, now compare and contrast the polymer A and B in terms of type of polymerization reaction. So polymerization reaction for the polymer A should be addition polymerization, or polymer B will be condensation polymerization. Okay, next compare the characteristics of the monomer. So for polymer A, monomer, it has the bond between the carbon bonds. Okay, yeah, carbon atoms. Meanwhile, for the polymer B, there is it has 2 functional group or 2 homologous series actually, okay, to form a polymer. Okay, next would be the section C. Okay, only 1 essay question is a compulsory question. Okay, question 11. Diagram shows the apparatus for the chemical cell. So it's a magnesium and the silver as the electrodes, and then put into the magnesium nitrate solution and then the silver nitrate solution, and then it has a salt bridge. So what is the meaning of redox reaction? So actually you can see the name redox. RED refer to reduction, or X refer to oxidation. So it's a chemical reaction where oxidation and reduction occur simultaneously or at the same time. Okay, now based on the diagram, identify the negative terminal and the positive terminal of the cell. Okay, now next write the overall ionic equation for the reaction, then write the cell notation. So you are given this Enoch value for the 2 half cells. Okay, here you can see magnesium and silver. Okay, so magnesium is more negative value, right? So this one should be the anode, no? Anode. Okay, negative terminal, so it undergoes oxidation, so the equation is more to left. Okay, meanwhile for this one is the positive terminal, cathode. Okay, equation will be more to right. Okay, actually you can see the negative and positive here. Okay, now so negative terminal should be magnesium or Mg, positive will be silver. Okay, next the overall ionic equation, right? So let's see the anode. Okay, magnesium lost electrons, anode oxidation, right? Lost electrons. Cathode gain electrons, right? Okay, gain electrons. Okay, so our purpose is to cancel the electrons. So here silver 1 electrons on it, so overall times 2, so meaning that this one becomes 2, 2, 2, correct? So we can cancel the E, so overall we just copy down Mg plus 2 Ag plus produce Mg2 plus and then plus 2 Ag. So this is the overall ionic equation. Okay, number 3. Okay, so here the cell notation. Okay, the rules is for the anode we will write first anode for the electrodes, followed by electrolytes, Okay, then double line shows the salt bridge or porous pot, and then followed by the cathode, okay, positive terminal, the electrolyte, and then the electrons. Okay, so the anode here we know is a magnesium, right? Magnesium. Okay, line, then magnesium ions is aqueous, right? And then 1 mole per cubic decimeter. So double line. Okay, also silver ions. Okay, and then line, then silver. So this is a cell notation. Okay, for this cell, chemical cell. Okay, question C. Diagram shows the apparatus set up to purify the copper metal, purification. So cell Q consists of impure and pure copper, right? Okay, so this one should be the electrolytic cell. Okay, then cell P should be the chemical cell to supply the electrical energy to the cell Q. So this one is a chemical cell as a battery. Okay, so for the chemical cell, let's see zinc and copper. So zinc is the E0 value is more negative. So more negative, so this one becomes the anode. Okay, negative. So this one is the anode. Okay, then this one copper is more positive, so this one becomes the cathode. Okay, so what happens to the anode here? The zinc will undergoes oxidation. Zinc lost electrons, forms the zinc ions. Okay, so what happens here? So zinc will ionize. Okay, zinc ionize or dissolve, becomes thinner. Okay, for the copper here. Okay, for the copper anode here, it's copper cathode here. So we look into the copper ions and then the hydrogen ions. So you have copper ions and then the hydrogen ions. So one of these will selectively discharge. Okay, so copper will be selectively discharged. So copper, you gain electrons, forms the copper. So your forms becomes thicker. So what happens to the copper 2 sulfate solution? Initially it will be blue color. Okay, so when it changed to copper, meaning that concentration of the copper 2 ions decrease. Okay, so meaning that the blue color will turn to light blue or turns to colorless. Okay, and then when it connect to cell Q here, so negative, so this one will be negative also, this one is positive. Okay, but here remember for the electrolytic cell, negative, we call it is the cathode. Then this is the anode. Okay, so since we know the anode and cathode here is using the pure and impure copper, right? So the anode, okay, it will take place in the reaction because it is active electrons. So the anode impure one, it will ionize, forms the electron, forms the copper 2 ions. So meaning that here will dissolve, the impure copper will dissolve. Okay, so the ions will go into here. Then at pure copper here, the negative undergoes cathode undergoes reduction. So you have copper and hydrogen. So again, copper 2 ions. Again, 2 electrons forms the copper metal. Okay, but here the blue color of copper 2 sulfate solution. Okay, if the copper 2 ions change to copper metal only, so the blue color turns to colorless or light blue. But here at the anode side, the copper 2 ions is produced. So meaning that the concentration of the copper 2 ions inside the electrolyte remain unchanged. So meaning that the blue solution remains. Okay, so no change. Okay, because there is supply of the copper 2 ions from the anode side. Okay, now look into the question. Okay, so given to you the E0 value, okay, so here you can have a look here. Now, cell P and cell Q. So cell P we know is an electrolytic cell. This one is chemical cell. So, okay, compare the observation on the color of the electrolytes. Okay, so explain your answer. So 5 marks. So first in cell P, cell P here. Okay, just now we can say blue color of the copper 2 sulfate solution becomes paler. Okay, or intensity of the blue color of the copper 2 sulfate solution decreases. Okay, but for the Q will remain unchanged, right? Okay, remain unchanged. Okay, why? Because the concentration for cell P of the copper 2 ions decrease. Okay, for cell Q remain unchanged. Okay, why? Why it decrease? Because copper 2 ions discharge to form the copper atom at the cathode. But for the cell Q, right? Okay, the rate of copper 2 ion discharge to form the copper atom at the cathode is equal to the rate of formation of the copper 2 ions at the anode. Okay, because the impure copper, it will ionize, undergoes oxidation to form the copper 2 ions. Okay. Okay, so table shows the part of the standard electrode potential. So given to you magnesium, zinc, iron, hydrogen, and copper. So you can have a look here. So the E naught value, right? The more negative one will becomes more easy to get to becomes the A naught, undergoes oxidation. Okay, the more positive one becomes the positive terminal, undergoes reduction. Okay, now diagram shows a list of material and apparatus provide to construct a vortex cell. Vortex cell. So we can have a look. So tomato, iron nail, plastic spoon, connecting wire, zinc strip, magnesium, sandpaper, LED bulb, copper wire, and then carbon rod. Okay, so not all the material and apparatus here are used. So you have to know which one to be used. So first we need to know the electrolyte. So only one got solution, that is the tomato. Okay. Now, by using your chemistry knowledge, draw the apparatus setup for a vortex cell that can light up the LED bulb. The apparatus setup construct should use the suitable material and apparatus given in the diagram. Describe briefly the steps to construct the vortex cell and explain the redox reaction take place. Then determines the value of the voltage reading obtained. Okay, here actually depends to which electrode you choose. So here I would suggest you to choose magnesium and copper. Then it is connected to this one is a LED bulb. And this is connecting wire. Okay, so connecting wire, one connect to magnesium, another one connect to copper. So this is using the tomato. So how to construct this chemical cell? So clean the magnesium and strip and the copper wire. Use the sandpaper. Okay, so all the metals need to be cleaned first. Then connect the magnesium strip and the copper wire to the LED bulb using the connecting wire. Then insert the magnesium strip and copper wire into the tomato. Then magnesium atom lost electrons to form some magnesium ions, or magnesium undergoes oxidation because its E naught value is more negative. Okay, then hydrogen gain the electrons to form the hydrogen gas. Okay, from the electrolyte actually for the tomato. It consists of the acid. So acid, it will ionize. Yeah, it contains the hydrogen ion, so it will gain electrons to form the hydrogen gas. Okay, so the cell voltage. Okay, we can use the E naught cell positive terminal minus the negative terminal. So the positive terminal will be the copper, right? Okay, copper. Negative terminal will be magnesium. Okay, or E naught cathode minus the E naught anode. So we can do the calculation. Okay, so it's plus 2.72 volt. Okay, 2.72 volt positive. Okay, then if you use the different pair of the metal, the E naught cell might be slightly different. Okay. Okay, so that's all for the SBP Trial Paper 2. Okay, so like this video, share this video with your friends. Thank you.